The diagram opposite shows graphs of the quadratic function f of x equals x squared plus 3x minus 1, where x is an element of the real number set, and the line L1. So this is our quadratic function, and this is the straight line L1. The line L1 passes through the point 2, 0, and is a tangent to the curve at the point minus 1, minus 3. So a tangent to a curve, a tangent is a line that touches the curve in one place. So clearly this is where our line touches the curve. Part A, find the slope of L1 using the slope formula. Part B, find f prime x, the derivative of f of x, and verify your answer to A above by finding the value of f prime x at x equals minus 1. And part C, the line L2 is perpendicular to L1 and is also a tangent to the curve f of x. Find the coordinates of the point at which L2 touches the curve. So part A, find the slope of L1 using the slope formula. So find the slope of this line. So what we have to do is take 2 points on our line. So we're going to take 2, 1 and minus 1, minus 3, because we were already told that L1 passes through 2, minus 3, and it touches the curve at the point minus 1, minus 3. So we know that these 2 points are definitely on the line. So we label them x1, y1, x2, y2. And our slope formula from our formula tables is m equals y2 minus y1 divided by x2 minus x1. So the m represents slope. So all we have to do here is just substitute into our formula. We swap y2 for minus 3. Bring over the minus. We swap y1 for 0. We swap x2 for minus 1. Bring over the minus. We swap x1 for 2. And then minus 3 minus 0 is just going to be minus 3. And minus 1 minus 2 is minus 3. And minus 3 divided by minus 3 is 1. So this line here, L1, has a slope of 1. B. Find f prime x, the derivative of f of x. Verify your answer to A above by finding the value of f prime x at x equals minus 1. So our function is f of x equals x squared plus 3x minus 1. And what we want to do is find f prime x, the derivative. So the rule for differentiating is we bring the power down in front and reduce the power by 1. So the derivative of x squared is going to be 2x, because we bring the 2 down in front, so we get 2 in front of the x, and we reduce this power by 1. 2 minus 1 is 1, and x to the power 1 is just x. So the derivative of x squared is just going to be 2x. Then the derivative of 3x is just going to be 3. We just cancel out the x because it has no power. And we can't differentiate minus 1 because it's a constant. It has no x attached. So the derivative of x squared plus 3x minus 1 is 2x plus 3. So if we want to verify our answer, we have to substitute x equal to minus 1. So we get f prime of minus 1 is going to be 2 multiplied by minus 1 plus 3. So all we've done here is swap this x for a minus 1. 2 multiplied by minus 1 is minus 2. And minus 2 plus 3 is 1. And 1 is what we got in part A for the slope of this line. So we have verified that our answer is correct. The line L2 is perpendicular to L1 and is also a tangent to the curve f of x. Find the coordinates of the point at which L2 touches the curve. So the slope of L1 is 1 at x equals minus 1. Therefore the slope of L2 will be minus 1 over 1, which is going to be minus 1. So the perpendicular slope is always going to be the reciprocal of that number and the sign changed. So if the slope of L1 was 1, then the reciprocal of that would be 1 over 1, which still gives us 1, and we change the plus to a minus. So if the slope of L1 is 1, then the slope of L2, which is perpendicular to it, is minus 1. So we let our derivative, which is 2x plus 3, be equal to minus 1. And then we just have to solve for x. So to get rid of this 3, we have to minus 3 to both sides. And minus 1 minus 3 is going to be minus 4. And then we have to get rid of the 2 by dividing by 2 on both sides. And minus 4 divided by 2 is going to be minus 2. So x is equal to minus 2. So then what we do is we substitute our x equal to minus 2 back into our original function. So we get f of minus 2 is going to be minus 2 squared plus 3 times minus 2 minus 1. Minus 2 squared is 4. 3 multiplied by minus 2 is minus 6. And then we have 4 minus 6 minus 1 gives us minus 3. So our point of contact is minus 2 minus 3. So we go to minus 2 on the x-axis, and we go to minus 3 on the y-axis, and that's our point right there. So that is the point of contact. That is the point at which our line L2, which is perpendicular to L1, touches our curve. So we knew that the lines are perpendicular to each other. So if L1 had a slope of 1, then L2 would have a slope of minus 1. We let our derivative equal to minus 1, and then we solved for x. And then when we had our x value, we substituted it back into the original equation to find our y value. And the x value and the y value together gave us our point of contact, that point there, which is minus 2 minus 3.